All right, up and running here. I'm going to do I've got all kinds of things written here that I don't usually see. Hopefully it's working fine. I'm going to do a quick video on the first 17 problems of your worksheet purely for practice. Repetition's your friend. If you're going to get a working knowledge, got to recognize, got to be able to deal with, and I don't think you get there unless you do it a lot. So we're going to do it a lot. All right, so I do two of each type. So problem one is equational line. I give you two examples. You feel free to move throughout the video where you want in terms of where you think you need practice. You do, even if you don't need practice, you start to gain insight about the algorithms that you're studying over time. So up to you. How hard do you want to work? I'm just gonna do the problems so I can hopefully be out of here. I got a lot of other things to do right now, so I'm just going to do them quickly, but you have the space bar. You can stop before I start talking about the one I'm on. You try it yourself and then check and see if you did it right. Or give me an email, tell me I did one wrong. All right, here we go. 5, 8. As soon as I see 5, 8, I'm writing x minus 5 and then 8. That's just the mechanics of getting the first point. From 5 to 9 is 4 units of change, and that's the x's. 8 to 21, that's 13 units of change. And so that connects these ordered pairs. Kind of like the fact that I went x is below. I usually go above, but since the change in x is in the denominator, that'll become a mnemonic device a little bit. It's easier over here to see the changes. So that's up, that's down 57. And that's the change in y. The change in x, -6 to 3, is up 9. So that's 9 units. And then it doesn't matter which point I use, but I'll use -6, 7. So x plus 6 gets me 7. All right, and that's the algorithm. I should say y equals, but this is going to be shortcut a little bit. Then we're over here. Let's see if we can move this desk a little bit as I go around. Okay, yep, you can see that board. What are we doing? A slope intercept, I think. So the mechanics of that are -3/7. I'm going to multiply x by -3 and then divide by 7. I'm going to multiply 2 times 9 -3 and then divide by 7. And I'll skip one step here. I know that if I'm going to express the number 5 in terms of sevenths, it's 35. Answer going to be positive or negative? It's going to be positive because the positive magnitude, that magnitude is bigger than the 6. So final answer, -3/7 x. Take 6 away from 35 is 29/7. And that's simply another way to express the same thing, the same calculation, just expressed differently. All right, so -2, you might want to put the 2 on this side as a first step. That saves me some writing. So that gives us 4/7 x plus 12/7. 2 is how many sevenths? It's 14/7. So final answer, 4/7 x plus 26/7. Moving right along. All right, let's see, what did I ask here? Probably 3 points. So what's the easiest number to work with? The easiest one to work with is 0. And if you put a 0 in, you get 8. So there's one coordinate. And since I'm dividing by 3, then I'm going to choose the multipliers, or the, what do they call them? I can't, names are evading me at the moment. The multiples, thank you. The multiples of 3. All right. And then that's the change in x. So the change in y is 5. 13, 18, 23. You can do that forever. Okay, same thing over here. The reason I'm giving you this problem is students in my calculus class didn't recognize this as a linear function. So this is another way of f of x is another way of saying the letter y. Came to us historically a little later. And x over 8 is the same thing as 1/8 x minus 7. And given the experience that I had in the fall, I'm going to start telling you now, right? Because you're going to want to know that if you go up to the next level. All right, so what do we got? Same thing here, another 0. I could have written this as x minus 0 in parentheses minus 7. Okay, no need for those other symbols. So 0 gets you -7. I'm going to go up by 1 for the y's, -6, -5, -4, so on and so forth. Change my x's by 8, so the multiples of 8, 16, 24. I keep doing that forever. So you get a lot of data that way. All right, here we go again. While I'm thinking of it now, and I might not remember tomorrow or Friday, at the end of every class, you want to be responsible for erasing the board and checking to make sure your chair's tucked in and any trash on the floor you dispose of. So 25 minus 4, we talked about the Greeks. So this problem is a subtraction statement. We want to make it as a multiplication statement, and 3 plus 2 times 3 minus 2 makes that happen. Okay, the middle terms cancel, and we get 25 minus 4, and these are obviously the square roots. So the sum of the square roots times the difference. Okay, and so if all of a sudden you know how to factor this, and you divide by 3 plus 2, over here, dividing by 3 plus 2, you can get the idea of why we pick it up as a skill. All right, so the next one, 7a plus 10b times 7a minus 10b. And you don't want to have to think about that. You want to just learn how to do it. So you see it, you just write it. That's workable knowledge. These are squares, by the way. Okay, b to the 6th is b squared cubed. So what's the square root of b to the 6th? I should have written it as b cubed squared. That would have been a better way to write that. That's the way I should have written it, because I'm after a square root. And so that gives me b to the 6th. So b to the 3 is the square root of b to the 6th. Obviously, I'm just dividing the exponent by 2. If I wanted a cube root, I would have divided by 3. So you're trying this, and the correct answer is square root of 4, 2. Square root of a squared, a. Square root of b to the 6th, b to the 3. And then I want to add the square root of 9c to the 10th, which is 3. C to the what? I hope you know. Divide by 2, 5. So that's the sum of the square roots. And I got to write this really small here. And that's 2ab cubed minus 3c to the 5. And then you got a little practice on that skill. All right. This is really the only thing new so far. You know, all those other problems back there, you should have done in Algebra 1, most of them in Algebra 1, and the others in Algebra 2. So we got a pi over 6. It's a 30-degree triangle. I don't think I want to write. I don't think I can go high enough with that. Well, I'll make it smaller and hope it works. There's your 30-degree. That doesn't look like a 30-degree triangle. I think I'll do it here and then erase. Okay, so that's pretty close, maybe. But that's a half, that's root 3 over 2, and this is 1. So Pythagoras says that the sine of 30 degrees, the sine of 30 degrees is a half. So instead of writing a half, I could have written the sine of 30 degrees. And if this was a different angle, then this becomes the sine of x. Any angle. The height in a unit circle, the height is the sine ratio. Therefore, root 3 over 2 is the cosine ratio. And what's Pythagoras say? Pythagoras says sine squared of an angle plus cosine squared of an angle equals 1. Why? Well, I guess I can't. Where can I draw this here? Maybe that'll fit. So that square area plus that square area equals that square area. That's my best attempt with shoulder problems. Yeah, so this is cosine squared x. Any angle, doesn't matter. Sine squared. Any angle, 1. That remains constant. So as this one goes up, as this side goes up and the area gets bigger, this has to get smaller proportionally. But the sum of the squares equal 1. So that's a 1. So is this. I'll do this one out. Sine of 4 pi over 3 is minus root 3 over 2. We're going to square that. Cosine is a half, negative 1/2, excuse me. We're going to square that. This becomes 3/4. This becomes 1/4. And by God, that does add up to 1. Moving right along. Okay. Do you remember what you did a couple of days ago? 2x minus 8y. Well, I suppose if you're seeing this tonight, what you did yesterday. All right, this is called standard form. How do you sketch standard form? X and Y intercepts. So the x-intercept is 20 and the y-intercept is -5. There's your line. Yeah, I didn't talk about that too much because I want you looking at it and going, where do you get those numbers? Hopefully you can see, because that's how you do the problem. Okay. Nice thing to talk about in math is it's written slightly differently. You understand it here, then move the 9. X-intercept 9/5, close to 2, so that now is 2 units. 3 times y is 9, that's 3. If that's 2, then this has got to be a little lower, and that's, wait a minute, +3, excuse me. So that's 2, maybe +3 is there, and there's your line. It doesn't hurt to know that a subtraction of x minus y is an increasing function, an addition of x and y decreasing. Might be helpful at some point, just to, check it out. All right, we're working on the 3 operations involved in exponential activity. So the minus sign is reciprocal. I might as well take one right now and make it 25/1. Of course, if you're really doing it, you don't need to write the over 1, so you can just stick with 25, and you have now performed that operation. We still have 3/2. We talked about roots in the denominator. I know the square root of 25 is 5. 5 cubed is 125. Now, we haven't done this in a while, but probably a good time to do it. My answer is 125 and my base is 1/25. So I could ask you the question and see if, I wish I'd put this on this sheet, but I'm just getting us started with review. Logs are review. So what's the exponent I put on top of a 125 to get 1/25 to get 125? The answer to that really was the work we just did a little while ago. And maybe you can see you need a cube root. You got to square it, you got to flip it. Maybe you can already kind of get a sense of what's going on. But to help, I'll put this one in a minute. But to help, we write an equation. So the word log means what? Exponent. Exponents go on top of bases. Well, there's your base, 1/25. And we want to get to 125. So what's the number that allows us to do that? Well, they're both base 5. So 1/25 is 5 to the -2. That's another way of writing 1/25. I'm going to raise that to the x power. 125 is 5 to the 3. Well, if the bases are equal, then -2x equals 3. And I hope you can see how we got the original question. What do I do with 1/25 raised to the, where the heck is it? Right here, -3/2. And that's this answer, -3/2. If I put that exponent on top of 1/25, we just did it a minute ago, replay it if you have to, you get 125. But the only way you're going to get these from me, and that's what you're after on every test, is a check next to the problem you did. Figure it out. All right, so now we got second problem, trying to give you 2 new problems just for practice. All right, what am I going to do first here? I'll do the cube root. The cube root of 1,000 is 10. 10 times 10 times 10 is 1,000. So I've done that operation. I'm going to square it. I've done that operation. Minus sign means to flip. Final answer 1/100. Hope that's starting to make more sense to you. All right, putting things in graphing form. We've been talking about, as soon as we want to sketch a parabola, a quadratic, a U-shaped graph, your brain has to immediately jump to -b/2a. That unlocks the problem. I'll show you another way you can do it that's a little quicker. All right, and if you like it, you can adopt it. But from a conceptual standpoint right now, we definitely want to have that number in our head. So this could have been written as 2x². That gets me the first term. I want to get 20, which means that I'm going to double this product and then double. So I really need 10 here, which gets doubled for 20. So I know it's got to be a 5, but let's do the minus b over 2a. So minus 20 might be negative 5 here. Doing it in this method, it is. So negative 5 is what's important. All right. And if we have a negative 5 times a negative 5, getting me 25, that is not the smallest area this can be. The smallest area is to make the dimension shorter. Okay, that's not 25 units anymore. I can still make that shorter. The dimension shorter, so that the area minimizes. How small can I make the area? Obviously 0. But we know we've got a negative 5 right now. That's the important number. So adding 5 to it will minimize the area. So this is just, negative 5 is just the center. Negative 5 is just what we call the axis of symmetry. It's the average of the roots. We haven't found the roots here, but we'll do that too in this problem. So it's the average of the roots. All right, so now what goes with a negative 5? I got to find the y value that matches up with a negative 5. Oh, I got an equation here that'll give me y values. If you give me an x value, I'll give you a y. So we put it in and we get 50. Therefore, that middle term, I'm not even looking. It's got to be minus 100. I haven't even looked. And then there's plus 5. So that's minus 50 plus 5. Looks like it's minus 45. Which means whatever table is created here, I'll just pick a random number. I'll pick 10, 200 plus 200, 405. I'll pick a 10 in this one. 10 plus 5, 15. Ooh, is 15 squared 215 or 225? It's 225. 225 times 2 is 450. 450 minus 45 is 405. Oh yeah, came out to be the same thing. The advantages of this, you can see the vertex, negative 5, negative 45. And I've been asking you to give me one more point on the curve. See if you can remember what one I wanted. Yeah, 0. If I put a 0 in, I get 25 times 2 is 50 minus 45, positive 5. That's how you can get a good sketch. Okay. Now, obviously, I did, talking here, I wasn't thinking, that is the y-intercept. I should have gone there. All right, why? I didn't, I don't know, I'm tired. But your y-intercept is always given, so you could, and we all have been talking a little bit about the y-intercept is on the same side as this sign. That's a plus, I'm on the increasing sign. If that had been a minus, I would have been on the decreasing sign, and that would have become a positive 5. So I think I'll show you what I do. All right, so I just locate 0, 7. I know I'm on the upside. So there we go. I'm on the upside. I now know that my x is negative, so I can even put in a negative, and this is the left of 0. And so all I do is divide 2 into 12 and cut in half. So 2 into 12 is 6, so cut in half is 3. Then I come over here and I go, well, that's 36, so that's 18, and that's add the 7, 25. So that gives me the y value. And just for real quick practice, to get back to this, to get back to that, from the graph itself, how do you do it? Well, I can see x plus 3 squared plus 25 is part of the graphing form. How far is it from 25 to 7? 32 units. How far is it from negative 3 to 0? Oh, did I butcher this thing? Yeah, I am tired. You can call me out on that one. Talking, not thinking. I'm going to come back to it here. Got to do it over again. I would have expected you not to make the mistake I just made. What was my big mistake? I hope it was 12x plus 7. I think that's what we have. Hey, that's a down shape, right? I think I got caught up talking about minimums. I don't know. I don't know what led me to not do that immediately, but I eventually saw it. So 0, 7 is on the increasing side over here. I think I probably saw the numbers not working here. And I'm saying, okay, I did something stupid. So that means that I'm on that side, which is positive 3. And what did we say it was? Well, I did something wrong. I didn't have this. I think maybe I didn't see it. So we got to throw the 3 in. So that's 36, cut in half is 18, plus 7 is 25. All right, so that gets me that quickly. Now let's see if that matches up with this, because before it didn't. That's the beauty of doing things to check. If you can come in from a different perspective and your perspectives don't match, that's how you find your errors. If all you do is repeat the way you did a problem, do it exactly the same way you did it the first time, you're liable to make the same mistake. So it's nice to come at things from different perspectives. All right, so what do we got? We got a 3 and a 25. So x minus 3 squared plus 25 is part of the graphing form. And now we want the change in x squared. The change in x is 3, the change in x squared is 9. And then we want the change in y, but I got to start from 25. I'm not reading left to right. I'm reading from where the pattern emanates. 25 minus 7 is down 18. Now I hope you can see where the -2 is coming from. If I went backwards 3 units and squared, I should have gone up 9. But I didn't go up 9. I went down, not drawing the scale here. I went down 18. That's not what happened. That's what's happened. So therefore, you've got yourself some cancellation. Okay, it doesn't matter what units you had over here. If this was stars squared, then I have 9 stars squared down here. The squared terms cancel just like numbers do. They divide out of the problem, which allows me to bring in some other unit of measurement. I don't think we talk about units of measurement enough. All right, I'm getting there. Play this video at any speed you want. What do we got here? You remember, you did this problem in class. Okay, this is just a line. Maybe I did that earlier. No, that was 3 points. Okay, good, fresh problem here. So the x-intercept is 8/3. A little less than 3, we'll call that 8/3. From the problem before, no, it's increasing. Maybe I did this. Anyway, let's get it over with. Dividing that gives me the y-intercept -2. So there's -2, there's the line. Let's do the same thing here. -5 into 10 is -10. And 7 into 50 is a little bit more than 7. Why the heck did I put that there? -10 over here, sorry. And a little more than 7. Oh, that's here. Okay, so something like that. Take more time with it. But that's what now I know. I did this problem before, right? So it's not that question. It's perpendicular. That's what's on the sheet. Don't have the sheet in front of me. So how do we find perpendicular? You got to find slope. Slope is about change. This number is not changing. If you see it change on the video, let me know. So I guess I am going to change it. I'm going to ignore it because it has nothing to do with slope. So therefore 3x equals 4y. I moved the y's because I don't like dividing by negatives. You make more mistakes. So we have a 3-to-4 ratio in the original problem. So what's perpendicular to 3/4? -4/3. And I want it to go through AB. So x minus a plus b. You need to know how to do that. All right. So we go and we look at our original problem. Our original problem was 3x minus 4y equals 8. And this is a crash course in review. So we can get to the pre-cal material that we got to get to. But if you got gaps here, got to close them. Got to be closed. -4 divided by 3 was there all along. 7 over -5. We don't put the negative in the denominator. So there's your perpendicular. I want to give you a cat. So I give you a cat, I'll get you a mouse. You give me a cat, I'll get you a mouse. So give me a cat. Now I'm going to get rid of the cat. I'm going to keep the mouse. In other words, it doesn't matter with symbols. Get rid of that first input and just write your output. That's a conversion. Now let's just make sure -7/5 works. So at this time, I'm going to move the x to the other side. 7y equals 5x. When I divide by 7, I get 5/7 for a slope of the original line. What is the perpendicular slope? If 5/7 is the original, the negative reciprocal. Oh yeah, we were right. All right, almost done. If I don't fall down here, we're good. All right, can you see everything? Yes. All right. Oh, I hope you think of mathematics, this term, as a language. I am speaking to you when I write that. I am speaking to you. Okay, do you know what I'm saying? Maybe yes, maybe no. First off, f of x could also be written as y equals. Okay? And this, from your previous levels of study, means to find an inverse. And so we have these things called ordered pairs, x's to y. Okay, let me give you an example of an x to a y. 3 to 9, 4 to 16, 5 to 25, 6 to 36. What am I doing to my x values? I'm squaring them. What am I doing to my y values to bring them back? Square rooting, right? If I'm squaring from left to right, I'm square rooting from right to left. That's an inverse of that particular calculation in this table. The only problem is we don't write functions in terms of, well, you can in calculus, you actually do. But we don't talk about functions in terms of y often. So we generally want to write things, calculations based on x. So I'm trying to find a calculation over here that, for instance, might take a 10, 55, 52, gets me 52. I want to create a calculation where a 52 for an x value gives me 10 for a y. Well, the first thing we notice is these are switched, right? They're switched. So we go here and we switch them. And then we simply solve for y, which is x minus 2 divided by 5. And then we check our new calculation. We drop in a 52. 52 minus 2 is 50. 50 divided by 5 is 10. We move on. We didn't make a mistake. Now, a much more difficult problem. Still review. What's the inverse of this? Well, I'm going to change that to y. I'm going to switch my x's and my y's. And I'm going to write my y's over here. I need space. I know that. And I'm going to do it with the eraser so that I make sure you can see what you're looking at. So right now we're here to y minus 3 plus 7. First thing I'm going to do is move the 7. Gone. Going to divide by 5. Gone. And this is where you hit the wall. This is where you're probably hitting the wall. What's the inverse of that? Well, let's take an easier example. 5 to the 2 equals 25. Did you also know that that exponent, 2, is the exponent you put on top? It's the value of the exponent you put on top of a 5 to get a 25? I think I'm using an exponent on the left, and the inverse is finding it. Okay, I'm trying to find the value of an exponent over here. What operation do we have that finds values of exponents? Log. And this log is a base 2. And I have done that inverse operation. Obviously, I need parentheses, and I got to add 3. Okay, so now I got to go back to what the original was on the left side, is the new one. On the right side, I start with a number, inverse operation, so that should be a minus 3. God, why is my brain so slow right now? Oh, it's right here. All right, so I was starting to create this, but I didn't want to have to do that in front of you right now because it takes a few moments. So what did I want to share? Oh yeah, you put a number in. So I'm going to put a number in that makes this part of the problem, pretty easy. And I want multiples of 4, but the number that I'm starting with is going to be off by 3. So for instance, a 7 minus 3 is 4 divided by 4. That's an easy number to work with. So is moving this up. I'll use an 11. So I'm going to use an 11. Okay, right for x. 11 minus 3, 8. 8 divided by 4, 2. 2 squared, 4 times 5, 27. So an 11 in the original function gets me 27. If a 27 doesn't get me 11 here, then I know I made a mistake. So let's put the 27 in. 27 minus 27, minus 7 is 20. 20 divided by 5 is 4. And then I'm hoping you are getting the language skills to know what you're looking for here. What does that mean? What does your brain say when you see log? Oh, I'm looking for the exponent. I put on top of a 2 to get a 4. Well, that's just a 2. I must have made a mistake, right? 2 plus 3 is not 11. So I got to go and do this again because I did something stupid. So let me change it from the get-go. So this is x. I don't know what I did. I might have subtracted 3. Who knows? Should be x minus 7 divided by 5. Then I want log base 2. And then where am I in this process? I'm at right here. So I got to multiply that by 4. I don't have enough room. So I got to multiply that by 4 because I'm not doing this video again. That's base 2. So I apologize for the stupid mistake I made. The only thing I got left is plus 3. All right, so I think I said here an 11 got us 27. I don't remember what mistake I made there, but let's look at this and see if it works. Oh, I can see this wasn't here before. I must have missed it, didn't see it. It's going to work now. So 27 minus 7 is 20. 20 divided by 5 is 4. We do the logarithm before the multiplication. The log is the exponent on top of a 2 that gives you a 4, which is a 2. I'm then going to multiply it by 4. Plus 3 is 11. Okay, so I started with a 27 in the second one, and I got an 11. It sure looked like I've got the proper inverse now. That's another example of a little different perspective to make sure you didn't do something stupid. And I did something stupid. Why? I'm really rushing. Right? Fire engines are red, and they're always Russian, so therefore fire engines must be Russian. All right, here we go. Minus 5/9. We got to make sure that we can do fraction work quickly and easily, so we practice it. So that's 15 over 45, plus I need a number over 45. 7 times 45. The way you want to do this is to break up 45 to be 40 plus 5. And then you can do it in your head. In your head, 280 plus 35, 315. Okay, now I can add those pretty easily. 330 over 45, and I'm not going to reduce it, but you certainly start with a division by 5 and also division by 3. How do I know that's divisible by 3? Add up the digits. Numerator, 3 plus 3 is 6. Does 3 go into 6? Yes, then it goes into this. 4 plus 5 is 9. Does 3 go into 9? Yes, then it goes into 45. So ultimately, I'm dividing by 15. All right, what are we looking for? Oh, a challenge question. No, it's not a challenge question. I was going to make you do the inverse. Minus 3/5. So that's minus 12/5, right? 4 times this is minus 12/5. When I square minus 3/5, the squaring gets me 9/25. Okay, that's doing the squaring. I still have to double that. So that becomes minus 12/5 plus 18/25. The easiest way to deal with this is multiply numerator and denominator by 5. And so that gets me minus 60 plus 18. I'll let you finish it from there. Over 25, and there's your fraction practice. What am I doing next? F of x equals 2. I gotta move your dad. Gotta move this. Okay. So on your worksheet, you had a question, f of x equals 2. Well, what's another name for f of x? It's over here. So that's what that goes to. Right? So another name for f, and that's what an equal sign means. An equal sign is may be written as. May be written as. In other words, 3 plus 2, that may be written as 5. And if I ask you to simplify something, that's simpler than that. And my definition of simplicity, that took me 1, 2, 3 strokes of the marker. This one took me 1 stroke of the marker. That's easier. That's general rule, that's true. So what may f of x be written as? f of x may be written as minus 3/2 x plus 7. Okay, and this is how I'd like to try to train your brain. In Algebra 1, you would have been asked to multiply by the reciprocal. Okay, and that's a little fuzzy in the brain. So see if this procedure makes more sense. G of x equals 5, I'll do that down here in a minute. See if this makes a little sense. I'm going to subtract 7. I'm going to do it in 2 steps. Division becomes multiplication. Multiplication becomes division. And a negative into a negative is a positive. I guess I'll show it. Some people drop the sign here and that's a mistake. That's a line you do not need to write. You could have come right here, 10 over 3. All right. Another one for you to try. Again, you're pausing the video each time, right? I'm going to stop saying that and hopefully you just inculcate it into your study habits. So G of x may be written as 4x plus 2x squared. Ah, this is going to be nasty. 4x plus 2x squared. I'm going to write it as 2x squared plus 4x equals 5. That's G of x. I could have written it that way. And I'm trying to find the number that creates a 5. So it's another equation. Okay. We always set quadratics to 0. And hope we can factor. I don't think you can factor that. So where do we go? Is there another way to write this? Okay, I'm going to go up because I'm running out of room here. So you're stuck. All right, so what do? Well, maybe you fall back on the quadratic formula. As far as I'm concerned, that's a pain. I don't think I've done anything with the quadratic formula in years, other than find out information as to whether the numbers are real, rational, irrational in certain situations. But for high school math, I don't suggest it. So what do we have? I'll do it 2 ways. One over here, the shortcut. The shortcut is I know a is 2. I also know that minus b over 2a is -1 in this case. So if I put a -1 in, I'm going to get 2 minus 4, -2 minus 5 is -7. And I know it's cup shape up. So I know that there's my vertex and 0's up here. I know what those x's are. This x is going to be centered at -1. And I'm going to the right. I'm going to go the square root of 7 divided by 2. That's it. Over here, I'm going to the left. That's -1 minus the square root of 7 over 2. And you might ask, well, how do you know that? Well, I know I'm at -7. To get to 0, I got to go up 7. That's where this number comes from. And I know whatever amount I have, I'm going to double it. So I better cut this in half, because if I double it, that gives me the 7 I need. But I also know that that quantity is going to get squared. So I better start with the square root. So it gives me the quantity I need after I double it. And I know I'm shifting away from the y-axis by 1 unit. Now, knowing that gives me the discussion we just had. All right. In other words, that could have been written this way. What are you going to do? You're going to go up 7. Right? Can't we see it here? We're at -7 for a y. Don't you have to go up 7? So hopefully that makes some sense. What's next? You're going to divide by 2 when you solve. Make that up higher. Right? Okay. Because of what we talked about a second ago. Then what? Squaring becomes what? The inverse. And +1. Did I make a mistake there? I hope not. No. So +1 is, so therefore, this is gone, this is gone, this is gone. Obviously, addition of 1 becomes -1 on the other side. And we could kind of highlight -1 there anyway. Now, did I really need to write this in graphic form? If I really take a deep dive and critically think about what's going on, every time I do a quadratic now, I'm saving precious seconds of my life so I can go to my passion, eating spaghetti and meatballs. No, that's not my passion. Okay, here we have an a term of 2, a -1, and a -7 as a vertex. Can you look at that and see what's going on? That's what's required of you as you go up the ladder now in math. Okay? It gets harder and harder and harder, which means you have to have more patience, more patience, more patience to not give up at looking at something. Yet this is the position you assume. I like my right hand. That's better. Little knuckle goes right there on the chin, and the thumb's got to come under, and it takes a little scratching right there. And then you look at the problem and a little frown, and you look at it, and you can go to yourself. You can say, I don't get that yet. The heck with it. I'll come back to it tomorrow. Oh, no, I do get it now. Oh, so you're trying to do that. Tangent of 2 pi over 3. I want to see some of the hockey guys play today. I know a bunch of them. So I want to get down to the game. Do I have time? Yes, I'm in good shape. Tangent of 2 pi over 3. All right, so I know 2 pi over 3 is here. I know that's -1/2. I know that's root 3 over 2. Okay, so tangent is opposite over adjacent. So root 3 over 2. Dividing by 1/2 is the same thing as multiplying by 2 over 1. Okay, so when you see fractions written like this with the same division, well, there's a shortcut. No, that's going to happen. So my answer is root 3. And I'm hoping that in the memorization sheet, I don't know if I sent it to you yet. I hope if I haven't, I know it's on one of the modules. I'm going to click publish. All right, publishing things that are helpful to memorize. It's helpful to know this amount. That amount is between the square root of 1 and the square root of 4. It's called the sandwich theorem. Okay, we know it's between those. Turns out it's 1.73 as an approximation. Okay, close enough, 1.73. And if you divide that by 2, that's where the 0.87 is coming from. All right, so that's that problem. 15's over here. So we talked about length times width equaling 0. Well, this is kind of in the length times width equals 0 format. Of course, we're doing less than. In order to do less than, you got to find the critical numbers. The critical numbers for the first parentheses, -4. The critical number for the second is 5. So we got a lot of numbers to consider. Do these numbers work? No, they do not work because I get 0 is not less than 0. Then the question is, these are called intervals. I have an interval here where my x values are less than -4. What I like to do, I don't want to give you too much here. I like to check. There's a way to tell you if things change or don't change. We'll have that discussion later. Right now, we have interval A, interval B, and interval C. I always check C and then just write the others in with a little trick. But for your purposes right now, let's check. All right, if I put a number bigger than 5 in here, 1,000,000. If I put 1,000,000 in here, I'm going to get a big positive number. 1,000,000 in here for x, that's a big positive number. A positive times a positive is not less than 0. So no. So I know this is yes, and I know this is no. Okay, and I'll tell you how I know that another time. But let's put a number between -4 and 5 to prove that the number we get when we do that calculation is indeed smaller than 0. All righty, so let's put 0 in. 0 in gets me 8. 0 in gets me -20, and 8 times -20 is -160. Is that number smaller than 0? Yes, it is. I'll let you plug in a number less than -4 to show that that's false. So we can either do interval notation, or if it's one interval, it's easier to say this. That's probably the easiest way to communicate. Okay, I'm hoping you had interval. Oh, you can tell I'm tired. I didn't have the screen on there. My fault. All right, well, not going to do it again. We'll do it in class. All right. Now, I'll give you a new one real quick. All right, new one real quick. I'm going to do a square this time. 3x minus something easy, yeah. 3x minus 6 squared times x plus 4. And let's be greater than 0. All right, so number line, identify, let's do less than or equal to, greater than or equal to. Again, -4 shows up. Over here, a 2 shows up. All right. Numbers bigger than 2, true or false? That's what I should be doing, true or false for you. I got the camera there this time, yeah. I'll put 1,000,000 in, 1,000,000 squared, big positive number, times another big positive number. That's definitely true. I'll put 2 in. 3 times 2 is 6. 6 minus 6 is 0. 0 squared is 0. 0 times 4, yeah, that's equal to 0. So 2 works. This number here is going to work as well because of the size of the exponent. It's even, but let's do it out and show you. Let's put a 0 in. 0 minus 6 is -6, but -6 squared is 36 times 4. Is that bigger than or equal to 0? Yes, it is true. This is the one that's going to be false. You pick a number less than -4, run it through, put the F there. So now we do have interval notation is necessary. So let's write interval notation for this particular one. Oh, no, I don't have to because it's equal all the way across. So all you had to do was say X is greater than or equal to -4. I was anticipating these not working, but they did work. So that's all you'd have to say. 2 more quick problems. Then I got to do the MLK stuff for you. Make sure I can figure out what I'm saying tomorrow. All right, so I just want to highlight inverse operations. Whenever you have a solitary X, I would not solve inverse operations if I had that. I would not do inverse operations. Hopefully you know what to do with this. So hopefully you know, factor it. 5x plus 9 equals 0, and you got your 0 and -9/5. But I don't have that here. I have 5x squared plus 9 equals 0. You feel free to do this. -9, -9/5, plus or minus the square root of -9/5. And whenever you have a negative sign, take it out and show the reader that you know that that's an imaginary number. Okay, so that's really lends itself nicely to inverse thought process. All right, 2 cosine x minus √3/2. Have you been finding cosine? Have you been working with things like the cosine of pi/6 or yeah, we have, and we've been getting answers like √3/2. So now you're asking you to think backwards. Okay, in other words, I'm giving you the value here. Well, I am after you, right? You're gonna, I don't want that question. I'm sorry. Just this. Let's just go cosine because I don't want to give you something you've worked with. So the cosine of an angle gets me positive √3/2. All right, and if we look at the unit circle, hang on. If we look at the unit circle is made up of 2 rulers. One ruler starts at -1 and goes all the way to +1. Same thing with the vertical ruler. But we want a horizontal ruler because cosine is all about the widths in the unit circle. So I'm going to erase the circle and do this problem backwards. Of course, you have to know what √3/2 is as a decimal, or you can't do it. So that's 0 and 0.87. 0.87 is out here. All right, now I bring in the circle. I say, okay, how do we measure widths? We measure widths, that's not the best circle. Okay, but we measure widths, vertical line. Oh, I can kind of start to see my picture here. √3/2, also underneath it, √3/2. There's 2 places. You recognize what angle. It's a terrible drawing because I'm talking to you. It should be a 30-degree drawing. So let me get a better drawing here. That's a better drawing. I hope you can see the √3/2 now, the 0.87. Remember, that's 1. So pi/6. 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like 11. You do that enough, and you don't have to count anymore. You just start to become familiar, very familiar with it, if you're practicing. If you're not practicing, forget it. It's just like any sport. You're not going to be as skillful as the person next to you. So it's just a question of how many reps you get. Trying to give you some more reps. It's going to be on the topics. This topic will be on every test. You'll get at least 1 question like this on every test the rest of the year. So it's really up to you how much work you want to put in. to start getting checks consistently on this topic and all the other topics. All right, so we're done. I'm getting out of here. Bye.